Let's look at Neutron under the hood by going through different deployment scenarios. Let's take a look at the components that are set up and integrated to have a working network as a service. So let's start by looking at Neutron deployed with Linux Bridge and Layer 3 high availability. Take for example this tenant. He has a very classic setup. An instance with a floating IP, a network with an associated subnet, in this case 172.31.0.0, a gateway for that network, which is a router with IP 0.1. The router also has an interface on the external network. If we take a closer look at the instance, we will notice that it has an IP address in the internal network, in this case 172.31.0.7, and it also has an associated floating IP, 203.0.113.8. So how is a router implemented in Neutron? A router is implemented in Neutron by creating a network namespace, which behaves as a typical gateway device. It has interface in different subnets. It can perform routing for east-west traffic. It can perform NAT for south to north traffic or north-south traffic. And it even runs VRRP as a redundancy for layer 3 workloads. VRRP? Yes. So this is the way layer 3 HA gets implemented. If we look at the Neutron layer 3 agent, take a setup where we have two controllers. Neutron layer 3 agent is actually running on both controllers. Not only that, but also each of these controllers has a special configuration in the neutron.conf file that sends this instruction to behave as a layer 3 HA. So for each router that the tenant has, a network namespace gets created in each of these controllers, or the machines running the layer 3 agent. How do we take a look at this network namespace? We do IPnet and slist. So here we see a queue router. We know that's the only router we have running. And now we can look at the interfaces that the router has to try to determine how that router is behaving. So loopback interface, internal interface from the 169.254 range to run the high availability protocol VRRP with the other network namespace that is also running in this other controller. In this case, this guy also has 169.254, but also the gateway address 172.31.0.1, and IP address in the external network, and the IP address for the floating IP of the instance of that tenant. Now, how is this network namespace connected to the main namespace? Here we have a hint. So we know that this interface is a beth pair with interface 11 from the main namespace, and this other interface has a beth pair with interface 13 of the main namespace. So who are interface 11 and 13? Tab 41F7 and tab 00EE. Where are these interfaces connected to? This is the part where Linux Bridge kicks in. So one interface in the external network, which also has the actual physical NIC that's connected to the outside world, and another tab interface, in this case tab 41F7, connected to the internal network for that tenant. How do we know that VXLAN 56 is the network for that tenant? We can determine that by looking at the networks that currently exist in Neutron. So OpenStack network list. These are the networks. Let's take a look at demo net 1. And we see that it has associated VXLAN 56. So how does north-south traffic traverse our setup? Let's say we have a client sitting in the outside who's trying to ping 203.0.113.8. So the first thing, when this packet comes into our cloud, it would hit the network namespace. In this case, Q router 539E. It would hit the public IP, the interface who's holding the floating IP. And of course, there is a NAT in this namespace that is available to perform the translation of these packets. So we have a NAT that says that anything that is destined to 203.0.113.8 must get translated into 172.31.0.7. So that's how the floating IP gets implemented. Now, once that packet has been translated, because it's translated to an IP address in this range, it will be forwarded to this interface. Where is that interface connected to? We determined that it's connected to this bridge. So that packet would just get forwarded out into the broadcast domain that's associated to VXLAN 56. This will reach that compute node who would have a similar bridge who also has an interface on VXLAN 56. But that bridge also has another interface, which is TAP4B. Who is the owner of TAP4B? Well, or instance. In this case, instance 06. How can we verify that? Verge, dump XML, instance 06. Here we see that the target device for its only interface is TAP4B. This guy right here. Now, there is one last step. The packet is also hitting another instance of IP tables. Not the IP tables in the controller that we're doing the NAT, but the IP tables in the compute that will actually perform or implement the security group rules that are associated to that instance. So if we do an IP table save, again, we will notice that we have this set of chains or IP tables chains, one of them being associated to TAP4B, which is the instance, which is telling him to forward all traffic to the group chain Neutron Linux Bridge security group chain, this guy right here. If we scroll down and we look at what that chain looks like, it's basically saying jump to that VM specific chain. In this case, Neutron Linux Bridge i4 BD. What does that chain state is that these are the rules for that instance. In this case, we are accepting ICMP traffic. These are the same rules that we will find right here in access and security. So we're accepting ICMP, port 21, and port 22 for SSH. And those are the same rules that we have right here. So port 21, port 22 for SSH, and ICMP. So this traffic will get accepted. A return directive will send us to the previous chain, which was in this case is Neutron Linux Bridge SG chain, which has a default action of accept. And that's our demo for Neutron with Linux Bridge and Layer 3 agent with high availability. Thank you.